Hey guys, welcome back to my YouTube channel, and today we'll get into the topic race conditions and immutable data, which is currency and all of that, dealing with currency issues in Java, icon and threads of warning signs. Current What is currency issues, right? It is doing two or more things at once that can cause unexpected result, which is shared and can be modified by multiple threads simultaneously. Example, Rian and Monica are sharing a bank and their account. Visual is cartoon of two people reaching for the same money, right? Now let's get into my notes that I did. Let me just go up. Am I in the right notes? Notepad. Oh, it's in my notepad. So we are dealing with currency issues. We are doing more than one thing at the same time that can be difficult, and it's the same when we are writing programs that use multiple threads. While it may seem easy to write code that uses threads, right? We are making sure that it can be worked correctly and can be much harder. So in this chapter, I will learn about common problems that can happen when threads run at the same time and how to avoid them, right? So what could possibly go wrong, and what could possibly go wrong when two or more threads run at the same time in a program? They might try to use or change the same data at once, but this can cause problems like data getting mixed up, wrong signals, or parts of the program behaving in unexpected ways. For example, one thread might be in the middle of updating a value while another thread is trying to read it, right? Now, which can lead to the confusion or errors. These kinds of issues happen when because the threads are not always of what the others are doing. They can interfere with each other if if not managed carefully, right? Let me do this because I cannot see nicely here. Okay, so now we go to page 641, which is marriage in trouble. Rian and Monica's problems is a great example of a race condition, which happens when two parts of a program, or in this case, two people, try to use or change the same data at the same time, and the result depends on who gets there first. Both of them looked at the bank account and saw $100, so they each thought it was safe to spend, but they don't know what happens that when the other person was doing what the other person was doing at the same time, right? So since Rian hasn't completed his purchase yet, Monica still shows the full $100. So she spent the money, and then Rian also completed his payment, and boom, they went over the time limit. This is exactly the kind of problem that we get in programming when multiple threads try to access and change the same time at the same time, right? Now the program behave unpredictably, just like Rian and Monica shared the account. These situations can be very tricky to fix unless we find a way to make sure that the data is either safely shared or can be changed while someone else is using it. Now let's see our code. We have 643. What did I say in 643? Let's see. 643, what is happening? Rian and Monica's example. The code example brings the Rian and Monica situation into programming using the threads, and the bank account class represents the shared bank account, starting with the $100. So there's only one account object, which means that both Rian and Monica are using the same account at the same time. But the Rian and Monica job class represents what each person does. So checking the balance, we are checking the balance and trying to spend the money. In the main method, we create one job for Rian who wants to spend $50 and one for Monica who wants to spend $100, and we run them using two threads in the executor service. So this setup allows both jobs to run at the same time, just like Rian and Monica shopping online at the same time. So each thread runs the go shopping method where it checks the balance and then spends the money if there's enough. So let's go and check the code. Now, as you can see, we have the bank account class. We have the main one, which is Rian and Monica test.java. We have both classes, Rian and Monica job and the bank account. What are we doing? We are creating a main class to run the program, which is Rian and Monica, Rian and Monica test class, right? And we are creating two jobs for Rian and for Monica. We're saying Rian Monica, we're declaring it to the new Rian and Monica job, which is Rian, and the account amount to spend is 50. And then Rian and Monica, we are declaring it to Rian and Monica job, which is Monica's account that is limited to up to $100, right? Then we're creating a thread pool with two threads to run the jobs at the same time, right? And then we are starting both jobs. They run in separate threads, which is executor.execute Rian and executor.execute Monica. Then what are we doing? We are shutting down the executor when the jobs are finished, right? And we are creating this class which has the tax that will each person will check their balance and the amount they spend. We have the name of the person, which is Rian or Monica, and here we are sharing the bank accounts, and we have the private final int amount to spend, how much this person wants to spend, right? And then we have Rian and Monica job, which has a string name inside it and the bank account, and we are initializing the amount to spend. Now we're declaring the name, the account, and the amount to spend. Then we're creating a method which is when the threads start and it will try to spend the money. Then we are simulating the shopping action and we are checking if there is money before we spend the money, right? Is there money that we're about to spend? And we're spending the money, then it finishes the spending. After that, it prints out sorry, the name of the person, of the account holder, Rian or Monica, sorry. And then we're creating a class which represents the bank account, which has the private balance, and we have the method to check the current balance. And then we're creating a method to spend money for the account to check if the account went below zero. Is it overdrawn, right? Now we're gonna play this and see what we get. I don't want to debug. As you can see, it says Rian is about to spend, right? And Rian finishes spending, Monica is about to spend overdrawn. So what did I say here in 643? I said the code example brings Rian and Monica's situation into programming using threads. So the bank account class represents the shared bank starting with $100, and there's only one account object, which means both Rian and Monica are using the same account at the same time, right? Then Rian and Monica's job class represents what each person does, checking the balance and trying to spend the money. So in the main method, we create the job for Rian and we create a job for Monica, which is what I showed you in the code. And we run them using the two threads in an executor service, right? Then this setup allows both of the jobs to run at the same time. As shown in the output, each thread runs the go shopping method and where it checks the balance and then spends the money if there's enough. So the problem is both threads might check the balance before either one spends anything. So they both think there's enough money and both spend, causing the account to be what? Overthrown. And this is called race condition, where the two threads race and it is used to share the data and the outcome depends on the timing. Now, this is what I get. Rian and Monica problem. Two threads access the same bank account and both check the balance and withdraw money concurrently and could result in overdrawn account. This is the code that we get. We're saying if the account is equal or less than the amount, spend the amount, right? And if else, say sorry, not enough, and the holder's account name, right? Now we use what we call synchronization. Synchronization is to make the code automatic. Lock the shared object, not the thread instead. We are preventing the race conditions. We're going to use class bank account and we're declaring it the $100. Then we use the method called what? Synchronized void spend string name and the int amount. If the balance is less than or equal to this amount, the balance must be equal or less than the amount. Print out this. So now we have the lost update problem. We are incrementing a shared variable which is not automatic, and two threads can override each other's update. As you can see here, this is an example that I did public synchronized void increment balance. Then we're using the alternative atomic integer, right? We're declaring it to the new integer, which is 0, and balance increment and get. These are short ways that we can resolve the program, right? So yeah, now let's go. Where is that? Let's go here. We want page, let me see. We want page 650, right? Let's go to page 650. Now 650, they say the dreaded loss update problem. Now we're having the what? The dreaded lost update problem. We have the lost update problem, which is a type of a race condition. This happens when the multiple threads try to change at the very same variable at the same time. So in this case, the program is trying to increment a balance, which is 1000 times using many threads. So we might expect the final result to be what? 1000, but often it will be less. That's because of the operation balance, and it is not actually a single action. It's really 3 steps. We read the value, we add 1, and we write the new value back. So if the two threads do this at the same time, they might not both read the same original value before either one updates it. So one update gets the loss, right? So this is what is happening in the lost update code. 1000 threads are each trying to call the increment method, but because there's no synchronization, many of those increments interfere with each other. Some threads end up writing over another thread's update without knowing it. The result is a final balance that's less than 1000. This shows why synchronization is so important in multi-threaded programs, to make sure that each update, it is to be shared with the data, and it must happen safely without being interrupted or overwritten by other threads. So what did I say about synchronization? Let's go back here. Synchronization, it is important because it makes the code automatic and locks the shared object, not the thread instead, the instance. So it prevents the race conditions. So let's see what we get here. The lost update, which is the problem. We getting this error now. Why are we getting this error? we're getting what? The final balance, which is 998. So what did we do? We created a class which demonstrates the loss update concurrency problem. Then we're creating a thread pool with 6 threads, right? Then these threads will all try to increment the balance at the same time. Then we are creating one shared balance, which is the object, right? And we are running 1000 tasks that each try to increment the balance. Each thread must run the increment. Then what are we doing? We are shutting down the pool so that it won't accept more than the task. Then what we do? We are saying if wait until all the threads finishes, the max wait must be equal to 1 minute. After that, we have our final method. Print all the final balance. So this is the final balance that we get. So we're saying run 1000 tasks that each try to increment the balance by 1. As you can see here, we did this for int I is equals to 0, less than 1000 plus II. Each thread runs the increment. That's why we get in this final balance. Now let's go to page 652. So now we're making the increment method automatic using the what method? The synchronized on the increment method, which solves the lost update problem because it ensures that only one thread can access the method at a time. This means that the steps involved in the balance plus reading the current value, adding 1 and writing it back are treated as a single uninterruptible action. So without synchronization, multiple threads might read the same value before either it writes it back, causing some updates to be lost. By synchronizing the method, we guarantee that each increment is going to be completed fully before another thread can make changes, keeping the data accurate and thread safe. So now let's test out the code and see if they are really sure about what they are talking about. Now, as you can see, we have a class. We're going to play this. We're going to see if now we have the balance, which is what? 1000, which is what we wanted, right? We getting that. Why are we getting 1000? We're getting 1000 because we use the method called synchronization. It is to make the code atomic and lock the shared object, not the thread instant. It prevents the race conditions and it adds them by what? By 1. As you can see here, this is the code snippet. That's why we get in the final result 1000. I hope you learned something from this vid, and I hope you click that subscribe button to view more of my content, and thank you.